Welcome to this class. Today we shall be discussing about applications of reflections of sound. And basically we have done that before, where we said an echo is a reflection of sound. And remember, whenever you talk about an echo, it means sound has traveled to a given object and it has been reflected back. So whenever you are looking at an echo, you look at an echo, you look at it from this angle, that sound has traveled twice the distance from where you are standing to that particular object and back. So we want to look at an example and be able to apply that concept. And the example reads, the speed of sound in air is 340 meters per second. A loudspeaker placed between two walls, A and B, but nearer to wall A than wall B, is sending out a constant sound pulses. How far is the speaker from wall B? If it is 200 meters from wall A, and the time between the two echoes received is 0.176. So the solution for this one is very simple. You look at the solution. The first thing you need to sketch. You need to sketch what is happening. We have been told that there is a speaker. Let us say our speaker is at this point. This is our speaker. This is our speaker. And we have been told we are having wall A. We are also having wall B. We have been told that a loudspeaker placed between two walls A and B, but nearer to wall A than wall B. That is why you can see I've placed the speaker close to wall A than wall B. Secondly, it is sending out a constant sound pulse. How far is the speaker from wall B? How far is the speaker from wall B if it is 200 meters from wall A? So it means the distance from wall A to the speaker is 200 meters. What we are looking for is the distance between the speaker and wall B. So let us take the distance between the speaker and wall B to be x meters. The distance between the speaker and the wall B to be x meters. We have also been told that the speed of sound is 340 meters per second. Also, what we have been told is the time interval. The time between the two echoes received is 0.176. What does that statement mean? It means that if there is a speaker here, because this sound will travel to wall A and it will be reflected back. Because the distance is shorter, the distance between wall A and the speaker is shorter compared with the distance between the speaker and wall B. It means once the speaker is set on, then it means you will be able to hear the first echo will be from wall A, because the distance will be able, the sound will be able to travel to this one and come back at a shorter time. Then after some time, you will be able to hear an echo from wall B, because now the distance is a little bit longer. And we have been told the time interval. The time between when you hear the first echo and the second echo is 0.176. We are supposed now to determine the distance between the speaker and wall B. So first of all, you need to write the speed. Speed of sound has been given as 340 meters per second. That is the speed of sound. We want to get the time. What time will it take the sound of the speaker to be heard at this particular point? Remember, the time will be equal to the time it will take it to move the wall A, then back. We know time 1, let time 1 be the time it will take an echo from wall A to be heard at this particular point. So that time is given by distance all over speed. We have been told the distance is 200 meters. But remember, because, like we have said, the sound will be able to travel to wall A, then back, so you have to multiply this, you have to double this distance. So it means you will take it as 2 times 200. Simply because the sound has to go to the wall A, then come back. So that is what we are saying. We have to double the distance divided by the speed, which is 340 meters per second. So then, of course, time 1 will be equal to, if you use your calculator, you will get it as 400 divided by 340. This becomes 400 all over 340. Because roughly you can take it as a 2 goes there 20 and 2 goes there 6, 17. Should be 17. Because that 4 divided by 2, you'll get 17. So our time T1 is equal to 20 over 17 seconds. Remember, this is now seconds. That is the time T1. We can get T2. T2 is the time it will take the sound to be heard here. So meaning the sound has to travel to wall B, then it comes back. So that one will be given by distance. Remember, we have said you have to double this distance. So it will be 2x divided by the speed, which is 340. 340. So our T2 basically will be equal to x all over 170. We have now been told the time interval. The time interval will be 0.176. So you will take, if you take x over 170 minus x all over 170, then you subtract that. X minus 170, x over 170 minus this one. So basically we are saying if you take T2 minus T1, you will be able to get 0.176. So our T2 is x over 170, our T1 is 20 all over 17, which will be equal to 0.176. So we can cross multiply here and see what we are getting. If you multiply by 170 across board, you will get x minus. So I'm saying multiply both sides. Multiply both sides by 170. You will get this becomes 200, and if you take 0.176 times 170, you will get 29.92. 29.92 is what you get there. Then of course now, your x, you'll have to take this one to the other side. It will be 29.92 plus 200. So therefore your x becomes 29.92 meters. So that becomes the distance between the speaker and the wall B. So the distance between the speaker and the wall B is 229.92 meters. 0.92 meters. So basically these are the steps you are required to go through before now you are able to determine this distance x. So now I want us to look into another example. Very fast. We can look at the second example. The second example reads, you having a ship which is floating in the ocean. Then we have a transmitter that is sending some sound to the seabed. And we are told that the ship above sends an ultrasound whose echo is received after 10 seconds. And we have said, if an echo is received in 10 seconds, then it means that sound takes 5 seconds. Take a half of this. It will take 10 seconds for the sound to travel from the transmitter to the seabed. But because an echo is double, that is why you can be able to see it is 10, meaning 5 times 2. So we are saying the transmitter sends a sound, to get to the seabed, it is reflected back. So the time it will take sound to travel from the ship to the seabed is equal to 10 divided by 2. If the wavelength of the sound of the ultrasound in water is 0.05 meters, the wavelength is 0.05, and the frequency of the transmitter is 50 kilohertz. Calculate the depth of the ocean. So what are we supposed to do for us to be able to calculate that? So the first thing is to get the velocity. You need to get the velocity of the wave. Velocity of the wave. Velocity of the wave, frequency is normally given by frequency times wavelength. Remember we say speed is given by frequency times lambda, whereby this is the frequency and this is the wavelength. So we can say the velocity of the wave will be given by the frequency. Where is the frequency? The frequency of the transmitter is 50 kilohertz. 50 kilohertz, you can write it in hertz. This is 50,000 hertz multiplied by the wavelength. We have been told the wavelength is 0.05 meters. So this becomes 0.05 meters. So velocity will be equal to 50,000 multiplied by 0.05 meters. So this becomes, if you multiply, it becomes 50 times 0.05, you get 2,500. You're getting 2,500 meters per second. That is the velocity. Now the next thing is, we have been told time. Time will be equal to 10 divided by 2, which gives us 5 seconds. Remember, we have been told it is taking 10 seconds for it to be received back, meaning it will have traveled twice the distance. So t is equals to 5 seconds. Remember, the question is, we are supposed to get the depth, which is the distance. We know distance. Distance is equal to speed times time. So the speed there is 2,500 meters per second times 5 seconds. Times 5 seconds. So what you will get is, if you multiply 2,500 times 5, you will get 12,500 meters. So you have now determined the distance, and that is the answer to that question. So the distance is 12,500 meters. We stop there, and that is the correct answer. Thank you.